let us start our exercise number 9.4. Before starting this exercise, we remember the formulas for previous lecture. What we have studied: sum of first and natural numbers, which is n into n plus 1 divided by 2. Then square of first and natural numbers, which is n into n plus 1 to n plus 1 divided by 6. Then cube of first and natural numbers, sum of cube of first and natural numbers, which is n square n plus 1 whole square divided by 4. Summation 1 is equals to n, summation k is equals to n into n plus 1 by 2. Summation k square, it is n into n plus 1 to n plus 1 by 6. Summation k cube, which is n square n plus 1 whole square divided by 4. Sometimes in this there is two patterns of sums over here, particularly in this exercise. Sometimes nth term is given and we have to find out sum of n terms, but sometimes n terms is not given. So first of all we have to find out n terms, means an, and then we go for the sum. Our same question is for all the exercises: find the sum of n terms of a series. In the question number 1, which is given that 1 into 2 plus 2 into 3 plus 3 into 4. So first of all, over here n terms is not given. So we have to find out the first of all n terms. What is n terms over here? See, 1 into 2. If we put 1, then 1 means a1 means first term. Like that nth term in which we can put, if we put 1, then we get this 1 into 2. If we put 2, then we get 2 into, we help to get 2 into 3. If we put 3, it means the third term is 3 into 4. So what is n terms? See, 1 into 2, it means n into n plus 1 is the n terms of n term of particular this series. If we put 1 over here, it is 1 into 1 plus 2. 1 plus 1 means 2. We get 1 into 2. If we put 2, means second term. 2 into 3. If we put 3, means 3 into 4. So our n terms for particular this series is n into n plus 1. By practicing out, we can find out easily the n terms of this type of examples and sums. So our n terms is n into n plus 1 by 2. Simplifying this, it can be n square plus n. We have won the Sn. Sn means summation k is equals to 1 to n ak. N is replaced by k because n is 4 here. So k is equals to 1 to n. Ak means n is n square plus 1. So ak means k square plus k. K square plus k. Multiplying this for both, k is equals to 1 to n k square, and k is equals to 1 to n k. For k square, as we know the formula, n into n plus 1 to n plus 1 divided by 6. In particular, k is equals to n into n plus 1 divided by 2. Common of the term n plus 1 and n plus 1. 2 from denominator, so it becomes n into n plus 1 divided by 2. Remaining term is 2n plus 1 divided by 6. 2 common, which means remaining 3 over here. Common out n into n plus 1 by 2. So remaining is 1. So multiply over here. So becomes n into n plus 1 divided by LCM is 3 over here, then 3 2s are 6. So over here it is 6. 3 1s are 3. 3 plus 1 is 4. And 2n plus 4. Again we go on out 2 from this both term. So it becomes 2n into n plus 1 n plus 2 divided by 2. 3s are 6. So it will be our answer. So again n into n plus 1 means n into n plus 1 whole square divided by 3. It will be our answer. Similarly, for next sum, question number 3, this is given 3 into 1 square, 5 into 2 square, 7 into 3 square, up to so on. So is our n over here? So first of all we have to find out an. So simply see over here for each and every term, 1 square, 2 square, 3 square. So one term we can guess that n square must be over here because for finding out the first term we want 1 square also. N square means putting 1, then 1 square, 2 means 2 square, 3 means 3 square. So n square is fixed, but what it is for 3, 5, 7 and so on. So for that, then 3, 5, 7, 9 and 11, it means they are odd terms. See, there are two types, one is even type and second one is odd type. So particular for even, when it is even terms which given over here, then you have to guess 2n over here. What is 2n? 2n means even terms, and particular for odd terms. You can guess two types. First is 2n minus 1 and second one is 2n plus 1. When each one can use, when each can one use for 2n minus 1, when use and when use 2n plus 1. So when our term is starting from 1, if we put 1, see over here we have to, if we put 1, term is starting from not 0, it's starting from 1. If we put 1 over here, then 2 ones are 2 minus 1, and term can get given 1. If we put 1 over here, then 2 ones are 2 plus 1, it means you get 3. We want 3 over here. So which term we have to be used over here? Second one, 2n plus 1. See, both term will give us odd numbers, which can be used where which term where can be used. So 2n minus 1 give us 1 and 2n plus 1 is give 3. But we want over here is number 3, so we have to use 2n plus 1 for odd terms. Can both can use, but particular for this special series we have to use 2n plus 1 over here. So our n term is 3, 5, 7. If you put 1, then we want 3. If you put 2, then we want 5. If you put 3, we want 7. See over here, 2 ones are 2 plus 1 is 3. If you have 2 twos are 4 plus 1, it is 5. 2 threes are 6 plus 1, it means 7. So our n terms is like 2n plus 1, and second one is 3, 1 square, 2 square, it means n square. So n square, n is equals to multiplying it into the bracket, and it becomes 2n cube plus n square. So particular for this special series, n term is n is equals to 2n cube plus n square. So we have to find out Sn. Sn is equals to summation k is equals to 1 to n ak. ak means n term of special series. So k is equals to 1 to n. What is ak over here? N is replaced by k. 2k cube plus k square multiply summation for the term is k is equals to 1 to n. 2 common out because it is constant, so 2 into k cube summation k is equals to 1 to n k square. So k cube means sum of cube of first n natural numbers, which is n square n plus 1 whole square divided by 4n. K square means sum of square of first n natural numbers, which is n into n plus 1 2n plus 1 divided by 6. 2 twos are 4. Common out term n square over here is n, so n common, n plus 1 also common, so n into n plus 1 n. 2 and 6, so 2 common over here. Remaining term over here is n square, 1 is common, remaining term is n into n plus 1 plus this term common, remaining is 2n plus 1 over 2 common, so term is 3. So n into n plus 1. LCM is 3. The 2 3s are 6. So n square plus n means 3n square. 3n square plus 3n plus 2n plus 1. So at the end n into n plus 1 divided by 6. And over here 3n square plus 3 plus 2 means 5n plus 1. Then our answer is n into n plus 1 by 6, which is Sn into 3n square plus 5n plus 1.